All right, let's talk about the invisible magic that pretty much makes the entire internet work. Seriously, it's something we use dozens, maybe even hundreds of times a day, but most of us never, ever see it. We're talking about the system that connects you to, well, to everything online.
I mean, it seems so simple, doesn't it? You type in a name, you hit enter, and poof, a website just appears. But have you ever stopped to wonder how your computer knows where www.example.com actually is among the billions and billions of devices connected to the internet? That's the big question we're going to tackle.
See, here's the heart of the matter. We humans, we think in words. We remember names like example.com. But computers, the internet, they speak a totally different language, a language of numbers, specifically these long strings called IP addresses. And that right there is a huge translation gap.
And that translation job? That falls to the hero of our story, the Domain Name System, or DNS for short. The absolute best way to think about it, and we're going to keep coming back to this, is that DNS is the internet's phone book. It just looks up the name you give it and finds the right number so your computer can make the call. So here's our game plan for digging into this. First, we'll see its job as an essential translator. Then, we'll uncover a secret shortcut your computer uses. After that, we'll see what happens when it has to ask the global phone book. We'll also check out the internet's massive family tree, and finally, we'll see how this all works today with DNS in the clouds.
Okay, let's start by following the journey of a single request. Just think of it like a little quest your web browser goes on every single time you click a link. And what's amazing is this whole journey happens in the blink of an eye.
Let's get a quick bird's-eye view of the whole trip. It kicks off when your browser asks for a website. Its first stop is to check something called the cache. That's just your computer's local memory. If the address isn't in there, then your computer has to go ask a special DNS server out on the internet. That server finds the right IP address and sends it back. And finally, your browser can connect. So now, let's break down the most important parts of that trip.
So, where does your computer look first? Not out on the big, wide internet. Nope, it looks right at home. It uses a secret little shortcut to make things way, way faster.
You know, before sending a request all the way across the globe, your computer does something really clever. It checks a local list of websites it's visited recently to see if it already knows the IP address. Why? Well, it's all about speed and efficiency.
And this leads to a really great way of thinking about it. If DNS is the giant phone book for the entire internet, then your computer's local cache is like its own personal mini phone book. It's full of numbers for the sites you go to all the time, so it doesn't have to look them up every single time. It saves precious milliseconds. But what happens when you visit a brand new website, or maybe one you haven't been to in a really long time? Well, that mini phone book comes up empty. And that's when your computer has to reach out and ask the global phone book.
So when those personal notes, the local cache, can't find what you're looking for, that's when the real journey begins. Your request now shoots out onto the internet, heading for a specialized DNS server. This is that huge, organized, global phone book we were talking about, a system with millions and millions of entries.
And here's the really smart part, the thing that makes this whole system get faster for you over time. Once that DNS server sends the IP address back, your computer doesn't just use it and forget it. No way. It writes it down in its own special notebook, the cache, so that the next time you visit, the answer is right there, instantly. The system literally learns from every request.
Okay, so we've seen how your computer asks a DNS server for an address. But how in the world can one system possibly keep track of every single website on the planet? Well, the simple answer is, it doesn't. Instead, the whole thing is brilliantly organized like a giant family tree.
Yeah, instead of one single, impossibly massive phone book, just picture this big tree of knowledge. At the very top, you have what it called the root servers. And from there, the system branches out, passing responsibility down the line. It's really a masterpiece of design.
So it works like this super fast referral system. Let's say you're looking for wikipedia.org. Your request goes to a root server first. Now, the root server doesn't know the final IP address, but it does know who's in charge of all the .org websites. So it points you to the .org server, and that server knows exactly who has the specific info for wikipedia.org. It's just this incredibly fast chain of command that pinpoints the right address in an instant. That whole tree system is amazing and super robust. But how does it handle the modern internet, with complex cloud computing? That's what we'll look at now, how DNS works in a world where websites aren't just sitting in one place anymore.
Think about it. A single service you use might be running on servers from Amazon, Google, and Microsoft all at the same time. And each of these clouds has its own way of naming things inside its own network. So DNS has to step in and be a super smart translator that understands all their different languages.
It's kind of like this. Imagine Cloud A and Cloud B speak different dialects on their own that have a hard time communicating. But DNS acts like a universal interpreter. It creates a common ground that lets them chat and work together like it's no big deal.
You know, the source material puts it in a really simple but powerful way. By translating between all these huge, complex systems, DNS basically helps them become friends. It just lets the whole digital world cooperate.
When you really stop and think about it, DNS is one of the true hidden heroes of our world. Its speed and reliability are what make everything from online shopping to binge-watching your favorite shows possible. It just works, tirelessly and invisibly, doing billions of translations a day to make sure that when you type a name, you get where you want to go.
And that entire journey we just mapped out, it all happens in milliseconds. It's this silent, invisible proof of incredible engineering. It really makes you wonder. DNS was built for an internet of connected computers. But as we move to an internet of connected everything, our cars, our coffee makers, you name it, what's the next great phone book going to look like? What will be the next invisible technology for a world we can't even imagine yet?